This is called hypothesis testing. Hypothesis testing. Right? Hypothesis testing. What is hypothesis? So, what is hypothesis? First, hypothesis. What is hypothesis? Anyone?
Imaginary thing we built.
Imaginary.
Imaginary thing we built according to that our wishes related to that subject.
Yeah. Okay. You said partially it is correct. Imaginary. Imaginary means whatever you imagine, can it come to true?
No.
No. So we'll have to be imagine whichever the possible, right? When possible imagination. So when you say imagine going to moon, you are thinking going to moon. Nowadays they are going to moon. Going to sun, that is imaginary. Can we say that is a kind of hypothesis? So after death you may go, but during this life, not possible, right? So that is, so we cannot include a term called as imaginary. Because imaginary you can achieve, you may not achieve in reality. But in a hypothesis, whatever we formulate or whatever we want to do a testing, that can be, there's a chance that can occur. There should be a chance that can occur. So that kind of statement you can imagine. So going to, as I said, sun. Is there a chance of going to sun? Anyone? No, isn't it? So no chance at all. Right? So putting up a statement like imaginary thing that can happen, not really. Whatever the imaginary thing that you think about it, it may should have some kind of chance to happen. Right? For example, going to USA. Somebody is imagining going to USA. So that is possible. Isn't it? Arosha. That is possible. Right? Going to USA is possible. Or going to UK is possible. So, I mean, let's say this is an imaginary that you are going to USA or UK. Right? So that is possible. So there is a chance to occur that event. Right. In Tamil, how do you call hypothesis? Direct translation. And Sinhala? Tamil and Sinhala, what is it?
In Sinhala, Upakalpa.
Upakalpa. Upakalpa. In Sinhala, Upakalpa. Upakalpa ඒක ක්‍රියාත්මක උපකල්පයක් වෙන්න ඕනේ නේ. ඒක ඇත්තටම උපකල්පයක් වෙන්න පුළුවන්. නමුත් ඒ උපකල්පය කොහොමරි ක්‍රියාත්මක වෙන්න ඕනේ. ඒ නිසා තමයි ඒක උපකල්පයක් කියන්නේ. දැන් හැම උපකල්පයක්ම ක්‍රියාත්මක වෙන්නේ නැහනේ. නේ? So that is upakalpa. Right. We will come to that the terms, right? What is in Tamil? Anyone?
Karuduhol.
Karuduhol, or sometimes call it as eduhol, right? Karuduhol, eduhol. In the Karuduhol and eduttal, the Karuduhol நடைமுறை சாத்தியமான கருதுகோளா இருக்கும். ரைட், நடைமுறை சாத்தியமான கருதுகோளா இருக்கும் அல்லது அதை கருதுகோளன்னு எடுக்கலாம். ரைட், so when you say hypothesis, it should occur. There is a chance or there is a possibility to happen that hypothesis. Then it is a real hypothesis that we can do the testing. If it is no chance of happening, no point of right testing that hypothesis. Right? Whether you said upakalpa or karaduvol, it has to happen. There should be some chance to happen. We don't know what is the chance to be happen. That is a different story. But it has to have some level of chance to happen. Right? So that is upakalpa or karadupo. That is called as hypothesis. Right? When you do the testing, right? Because we are going to do a lot of testing in our course also. During the testing, the first thing that you will have to do is you will have to formulate your hypothesis. Maybe in your final year, when you come to your final year second semester, you will do your individual or independent study, which is called as directed study or project or whatever you can call it. There you will do a small study, right? In that study, you will incorporate the main component at the initial as the hypothesis of that particular study. Hypothesis of that particular study, right? Suppose, let's say, I'm taking 4 paddy variety. Right? I'm going to test in the field. Only 4 paddy variety. So my hypothesis is to see, right, whether there is difference in the yield among these 4 varieties. Isn't it? That is my objective. So I don't know really. I have 4 varieties. So my supervisor has given 4 different paddy variety and asked me to sow it in the field and study which variety giving high yield per unit area. Okay, which variety is giving high yield per unit area. So as a student, I want to do a small study using these 4 variety and come to a kind of decision which variety giving more yield. Before that, whether all the varieties are giving the same yield or 1 or 2 variety may give higher yield, other 1 or 2 variety may give lower yield. So this is what we call as hypothesis. In our study, it is called as hypothesis. Right? In my study, in paddy study, 4 variety, comparing 4 varieties yield, that is what I am going to do. So that is what I am going to test it. Right? So that is called as hypothesis, basically. Right? Hypothesis that can be tested. Is it clear? Hypothesis. I just gave a very detailed introduction of the hypothesis. There are so many things to be discussed. I will come to that. Hypothesis means it is a statement. In simple term, it is a statement. Hypothesis is a statement. For example, all 4 varieties are having same yield. That is what I am going to test it, for example. Okay, all varieties are having same yield. So that is a statement. So hypothesis we can test, right? So that statement could be tested, right? Any questions? I just started with the hypothesis. I am going much deeper into the hypothesis further. Any questions? Right. This hypothesis, we said that it is a statement. This statement will be based on your objective of the study. So we said it is a kind of statement that we are going to do the testing, right? But how we can write that statement, that is totally depend on my objective of the study. For example, as I said, testing 4 varieties. So my objective is to test these 4 varieties, whether these 4 varieties are giving same yield or whether they are giving different yield. So that is my objective. So based on that objective, I can formulate my hypothesis. So when you come to your final year, everybody will have your own set of hypotheses, right? Own set of hypotheses. You can test the hypothesis using testing. We will come to that testing later on, right? First, we will see how to formulate your hypothesis. Right, when you are formulating hypothesis, there are 2 types of hypothesis available. One is called as null hypothesis. I will explain what is that. This is indicated as H0. Null hypothesis usually indicated as H0. Right? The second one is called as alternative hypothesis. That is given as H1, or sometimes in certain books it is given as H8. Right? So this hypothesis formulation, or the statement that I said, formulating the hypothesis statement, has 2 types. 2 types of statement. One is called as null hypothesis. The other one is called as alternative hypothesis. Null and the alternative hypothesis. In our examples, also we will state how to develop a null hypothesis, how to develop an alternative hypothesis based on our objective. Right? How many types of hypotheses are there? 2 types of hypothesis. One is called as null hypothesis, alternative the second one is called as alternative hypothesis. The speciality of these 2 hypotheses are they are mutually exclusive. So they are called as mutually exclusive. Can somebody tell me what is mutually exclusive? It is a English term. What is mutually exclusive? Anyone? This null and the alternative are mutually exclusive. Yeah. Anyone?
They act together.
They act together. If they don't act together, how do you call? In mathematics,
Independent.
independent. Yes, independent. This is mutually exclusive mean independent, because maybe in probability, in Venn diagram in mathematics, you might have heard about mutually exclusive. The term is mutually exclusive, right? Right? So what do you mean by mutually exclusive? They are independent. That means, in another term, if this happens, this will not happen. Or if this happens, this will not happen. So that means if one happens, the other one will not happen. So that is the simplest explanation. Yeah.
So it means that both cannot occur in same time.
Exactly. If one happens, the other one will not happen. Suppose if H0 is happening, H1 will not happen. If H1 happen, H0 will not happen. So in other term, at the same time, both cannot will happen. For example, let's take a simple example. Today I am at home. Today I am going to Colombo. Oh, nowadays Colombo is curfew, so I cannot go to Colombo. Let's say I am going to Anuradhapura. So one statement is I am at home. My null statement is I am at home. My alternative statement is at Anuradhapura. Can it happen both simultaneously?
Can't.
No, it cannot happen simultaneously. So, if it happens, if I am at Anuradhapura, definitely I am not at home. If I am at home, definitely I am not at Anuradhapura. Right? Similarly, another example. Today, no rain. Alternative will be today there is no rain. Can somebody tell me what would be the alternative in raining? Today, no rain or no raining. Today, no raining. What is the alternative?
Today rain.
Yes, today there will be rain. Today will be raining. So you cannot see both happening at the same time. If this happens, this will not happen. If this happens, this will not happen. Right? So this is the difference between null and the alternative hypothesis. Right? You'll have to write down notes, right? I'm not going to give any extra notes. So whatever the document, you write it. So null and the alternative are called as mutually exclusive. So if one statement happens, the second statement will not happen. Okay? We will see how to formulate our null and the alternative in few minutes. But as I said, when you formulate these two are mutually exclusive. So these two are the statement that we are going to test it using our information, our data. Or through data analysis, we are going to come to a conclusion whether we can adhere to the null hypothesis or whether we can adhere to our alternative hypothesis. We cannot say we are adhering or we are accepting both, because at a time you can accept only one. Is it clear? So that means if it is raining, no problem. It is today, it's raining. So we accept that. Can we say today no rain at the time it's raining? No, it is wrong. This is wrong, this is right. Because today it's raining, for example. Right? So we cannot accept both statements together. At a time, we will accept only one statement. So accepting or not accepting, or accepting or rejecting this statement will be based on our statistical calculations that we will see later. But this is what we call as hypothesis formulation, right? This is what we call as hypothesis formulation. So basically we formulate two statements. One is called as null hypothesis. The other one is called as alternative hypothesis. Right. How we can decide which could be null hypothesis, which could be alternative hypothesis? How are we going to decide the null hypothesis and the alternative hypothesis? Simply, if you define the null hypothesis, the null hypothesis definition will go as it refers to the reference population. It refers it refers to the reference population where we know the mean. So make a note of it. It refers to the reference population. We will talk about, you know what is population. It refers to the reference population where we know the mean. For the time being, you just write down and listen very carefully. I will take an example. Right? Let's say in the irrigation water, I'm going to use this for irrigation. I'm going to use this water for irrigation, right? Nowadays, there are some problems when you irrigate water from the well, for example, or water from the well, which is much closer to the sea level. Maybe the area like Kalpiti, Mana, you cannot use the groundwater for the irrigation. Can somebody tell me from Mena and Putlam area or even other parts of coastal area, what is the problem of irrigating water? What is the problem with the irrigation water? Yeah?
Hardness.
Yeah, hardness is not a very problematic for crops. Hardness
Salinity.
is not very problematic for crops. Hardness is problem for whom?
For us.
For us, for human consumption, for animal consumption. That is a problem. Hardness is not a problem for plants. Plants because
Salinity.
exactly salinity. Salinity is a problem because it is already dissolved in the water. Right? It is already dissolved in the water. Where plant absorb water which is already having some level of salinity. How do we measure salinity? Anyone? How do we measure salinity? You have done this in water quality.
Kc by Kc.
Yeah, once again.
Kc. Hydraulic conductivity.
What conductivity? What conductivity? Yeah. Chamara, how do we measure salinity? Chamara Herath. Huh? Chamara Herath. Suganya, how do we measure salinity? What is the unit measuring salinity?
By electrical conductivity.
Exactly. Easy. Electrical conductivity. Easy. Right. I'm not teaching agriculture engineering, but you should know. What is electrical conductivity? Usually, what is the unit that we are using? Anyone?
Electrical conductivity.
Yeah, we are using EC meter to find out the value, but it's the unit that we are using. Anyone? Unit, if you can remember. Have you measured EC in your sample during your practical hours?
Microsiemens per centimeter.
Yes, microsiemens per
Centimeter.
yeah, good. Microsiemens per centimeter or Siemens per meter. Different units are there. Microsiemens per centimeter, right? Microsiemens per centimeter. Different units are there. Okay, but let's say microsiemens per centimeter. Let's assume this particular irrigation water is normally, let's assume this is saline water. We don't know how saline that it is, right? Now we are going to irrigate this into our land. Now I am going to do a small study on this, whether this water is suitable for irrigation or not suitable for irrigation, based on the salinity level of this water. Suppose if you say 3 microsiemens per centimeter is the borderline. So that means if any water containing with the salinity level of 3 microsiemens will be considered as not suitable for irrigation. It will create problem in the plants or the crops, which lead to the wilting of the plants, etc., etc. So we say this is the border. So this is the standard. For example, this standard. This is the standard that is available in the literature, in the books. So normally irrigation with irrigating with 3 micro Siemens per centimeter, water will lead to the wilting of the plant. So do you think this water is good for irrigation?
No.
No. If it is equal to 3, it is not good for irrigation purpose. If it is more than 3, is it good for irrigation?
No.
No. So to be irrigatable water, what could be the possibility of the EC?
Less than 3.
Less than 3. Good. So here my objective is to study this water, whether this water is suitable for irrigation. That is my objective. My objective is to study whether this water is suitable for irrigation, whereas we know some facts that if it is equal to 3 micro Siemens per centimeter, mean that is not good for the irrigation. That means it will lead to the failure of the crop. So what I do is, since I am going to study this, my null hypothesis, look at this, it is the mean of the reference population, where we know the mean of the reference population. That is how we can formulate null hypothesis. This is the reference population. So my mean is equal. So this is my null hypothesis. Alternative hypothesis. If it is 3, can we irrigate?
Can't.
If it is 3, can we irrigate? No,
Can't.
we can't. So what could be the alternative hypothesis? It should be irrigatable, because we said if it is 3, we cannot irrigate. The alternative, always we said mutually exclusive, so that we'll have to write the statement in a way that we should be able to irrigate the water. So how I can write this? The alternative?
Less 3. Less than 3.
Less than 3. Good. So mu is less than 3. So you see, this is how I do write my hypothesis, null hypothesis and alternative hypothesis. This is based on my study. We will see that later, how to test this and so on, using the data, etc. But this is how I formulate my null hypothesis and the alternative hypothesis. Right? When you formulate this null hypothesis and alternative hypothesis, I will erase this. There are different ways to formulate your null and the alternative hypothesis. This is one way, right? So this we can write this way, or null hypothesis mu greater than or equal 3, alternative mu less than 3. Is there a difference between these two? Is there a difference between these two? That means if it is equal 3 or above 3, we cannot use that for irrigation. This is same in our hypothesis testing according to our objective. This is same. Is it clear? Because if any value gets 3 or above 3, definitely that water cannot be used. Any questions? If you don't ask questions, I will ask questions, right? So we can write in this situation either this way or this way. This is my null hypothesis, this is also. So here I come to a conclusion if I accept this, I use the data, some data from here. I will do some water sample collection. I will get some data. So using that data, I will see whether I can, based on that data, whether I can accept H0, whether I can accept H1. So if you accept H0 based on the data, what is your final conclusion?
Water is not suitable for the irrigation.
Exactly, water is not suitable for irrigation. Based on our data, if I come to a conclusion that I accept alternative hypothesis,
Water is suitable for the irrigation.
water is suitable, right? Okay, so this is how we make the conclusions. We will come to that later with some practical sum, etc. probably next week. But today we will focus on the principles, theories. Right, so this is how we can formulate our null and the alternative hypothesis. Look at another example. I'm taking farmers in Kilnati. Farmers, paddy farmers. Huh? Paddy farmers in Kilnati districts. I'm getting some information from them. What is their average yield per hectare? What is their average yield per hectare? Can somebody tell me what is the national average of paddy in Sri Lanka? I'll have to ask from once again.
4.4 metric ton per hectare.
Good. Okay, we will assume that national average is 4.4 metric ton per hectare. 4.4 metric ton per hectare. Right. My objective in this study, because I have some sample from farmers, paddy farmers from Kilnati district. Now, my objective is to see whether the average yield of farmers in the paddy farmers in the Kilnati district having same yield as national average, or they don't have same yield as national average. So that is my objective. My objective, write down the objective. What I say is, I want to see whether the average yield of paddy farmers in Kilnati district, do they have same yield as national average or not? So that is what I am going to test. Clear? Right. Now, what is my null hypothesis? Mu. What is my null hypothesis? Mu. That mu is coming from this data. So this, right? Mu is coming from this data. So I am getting the data from there. So the mean value, population mean value of which is coming from that data, whether that is equal to 4.4. So don't forget that it is known as the mean value of the reference population. So my null hypothesis is mu is equal 4.4. What is my objective? I want to see whether the average yield of paddy farmers in Kilnati district having the same yield as national average or not. I said or not. So what is the alternative hypothesis? Mu. Did I want to?
Is that
Is that my objective is to see whether it is higher than or lower than? No. I said whether they are equal to, test whether they are equal to 4.4 or not. So the alternative hypothesis will be somebody
Not equal.
not equal to 4.5. So this is, you see, this way also we can formulate hypothesis. This way also we can formulate our hypothesis. So by looking at this alternative hypothesis are totally depend on what is my objective of the study. So here my objective of the study is slightly different, whether that water can be used. So here I want to test whether it is different from 4.4 or not different from 4.4. So my null is like this and alternative like that. So we will come to further some examples later on how to formulate your null and the alternative. We will come to that. Any questions? Any questions? Any questions?
Rective.
Yeah?
Can I talk in Tamil?
Yeah, sure.
The null hypothesis தான் நம்ம பாசிட்டிவான ரிசல்ட்ஸ் தரமன்னு எடுக்கலாம்.
Blange.
null alternative hypothesis ரெண்டு இருக்குது.
Yeah.
null hypothesis தான் பாசிட்டிவா இருக்கு. நாங்க எடுக்கிற எடுகோளுக்கு அதுதான் ஈக்குவல் படுத்துறோம். அதுக்கு எதிர்மாறு ஆல்டர்னேட்டிவ் கொண்டு வரோம்.
இல்ல, that is based on the reference population. அதாவது நாங்கள் எடுக்கிற எங்களுக்கு அந்த ஏற்கனவே அறிஞ்ச ஏதாவது பாப்புலேஷன் இன்ஃபர்மேஷனை வச்சு தான் அதை ஃபார்முலேட் பண்றோம் null hypothesis.
அதுக்கு ஆப்போசிட்டா ஆல்டர்னேட்டிவ் பண்றோம்.
அதுக்கு ஆப்போசிட் அண்ட் அது இப்ப எங்கட ஆப்ஜெக்டிவோட போகணும். It has to be go with objective and it should be alternative should be mutually exclusive. அதாவது if H naught happens, H1 will not happen. Alternative. Because you cannot have both happening together.
Thank you.
First, you'll have to formulate your null hypothesis. First, you'll have to formulate your null hypothesis. That is based on the statement given. Usually, that is the case. It is equal to the reference population. Usually, that is the case. Right? The alternative depend on what is your objective. In our objective here is, we said, no difference. Test whether no difference with national average. That is what my objective. My objective is nothing else other than that. I didn't ask to look at whether it is greater than national average or less than national average. No. My task is to see whether it is equal to 4.4 or not equal to 4.4. So this may be less than 4.4 and this may be greater than 4.4. That is not my objective. That is not my objective. My objective is to see whether it is different from national average. That's all. Right? Suppose if I ask the question slightly differently, test whether it is higher than national average. If it is higher than national average, how do you write this alternative? If my objective to be test whether the farmers, average yield of farmers, paddy farmers from Kilnochi district is higher than the national average, how do you write?
Less than 4.4.
Huh? Curly Gattingal, can you answer?
If it is less than average, then
my objective is I want to test whether the average paddy yield from farmers from Kilnochi district higher than the national average.
And then H naught equal to mu equal to greater than 4.5.
Exactly. So we'll have to say mu greater than 4.4 because that is what I am going to test it.
Yes.
Right? Alternative is, now my objective is different. My objective is, earlier my objective is see whether it is equal or not equal. That's all. Now my objective is see whether it is greater than national average. So null will not change. Alternative will change. You see? So depend on how do we ask questions. So what is my objective? It is decided by this alternative hypothesis. So null hypothesis mainly it's based on the reference population, right? So once we do so many examples, we will get to know how to do it, right? Any questions? Any you can ask questions in any language, no problem. No restriction in asking questions. Yeah. Anyone would like to ask questions? Fine. If not, we will proceed. Right. Now, I want to take an example. I'm not sure whether I can use the different color pen. Let's see. I'm taking the average paddy yield. Again, I'm taking average paddy yield from two districts. Right? Distribution of average paddy yield from two districts. Can you name two districts, low paddy value and high paddy value, average? Anyone? High paddy producing area and low paddy producing area in terms of metric ton per hectare. Anyone? All are from abroad, maybe, huh? No one from Sri Lanka. Hmm? Where do you get high paddy yield in Sri Lanka per unit area? Hmm? Yeah, somebody said the high is in Kurunagala, low in Jaffna. So we will take that example. So how high? Maybe somebody might come from Ampara might say the paddy yield, average paddy yield is coming high basically from Ampara. That is also possible. So it changes from time to time. Yeah. Can you give me some figures? Maybe, yeah, right. So for our example, we will take that, right? Right. High paddy yield coming from Kurunagala, right? Low paddy yield from, I will take two districts, Kurunagala and Jaffna, right? I take two districts. Basically, one with low paddy yield, the other one is with high paddy yield, right? Two districts. Let's say paddy, the average paddy yield, the average paddy yield from Kurunagala, average paddy yield from Kurunagala is distributed normally with the mean of this is height of 6 metric ton per hectare. Right, so that is one thing. Second thing, the average paddy yield from Jaffna distributed normally with the mean of 4 metric ton per hectare. I will take some example, right? This is for our study. So basically, we say the average paddy yield of Kurunegala districts distributed with a mean of 6 metric ton per hectare, whereas the average paddy yield of Jaffna distributed again normally with a mean of 4 metric ton per hectare. So I'm going to draw a distribution graph for these two information, right? These two information. Let's see. Wait until I finishes the graph. Huh? I'm not expert on drawing. Right, now I have two distribution. Can you all see the color difference? One is in red color distribution, the other one is black color distribution. Yes? Yes or no? Yeah? Chamara is, are you around?
Yes,
Devani
sir.
para kata kara. Chamara inna, then mic ke on kara. Yeah, Chamara, are you around?
Yes, sir.
All right. Can you see the difference? Color difference? You know, Spain or that?
Somewhat difficult, sir.
Aye.
That's it. Same color.
Same color, I am using black color and red color. Difficult.
Difficult.
Difficult. Okay, right. Can you see these distributions are wider apart? You can dura distribution dekama තියෙන එක පේනවද? නැත්නම් එකම ගොඩේද පේන්නේ? චාමර. හා?
අවුලක් නැහැ, sir.
එකම ගොඩේද distribution දෙකම පේන්නේ නැත්නම් තන් දෙකේ පේනවා වගේ පේනවද? නැත්නම්
අවුලක් නැහැ, sir.
හා?
තැන් දෙකේ වගේ පේනවා, sir.
Ah, right. Okay. Right. No. I want to just to clarify whether you all are having clear visuals. Otherwise, something wrong with the camera. Right. So this distribution. So I'm going to talk about these two distribution. One is from Kurunegala. One is from what do you call Jaffna. Can you tell me which is Kurunegala, which is Jaffna distribution? This is on a scale. Huh? This is on a scale. Tell me. Which is
Black one is Jaffna.
which one is Jaffna?
Black one.
Yeah, black. Oh, we will say left and right. Huh? Some people cannot see the color. So the left distribution is basically from Jaffna because the average paddy yield, mean paddy yield of Jaffna is 4 metric ton per hectare. Mean paddy yield of Kurunagala district is 6 metric ton. So this is 4 metric ton. This is 6 metric ton. Right? So I have the distribution. I have the distribution. Right. Now I'm going to ask a question whether I'm getting a sample, right? I'm getting a big sample. Let's say n is 20. So number of sample is 20 samples from a group of farmers. We don't know which, I mean, they are basically coming from either Kurunagala or Jaffna. We don't know where does they come from. Where does they come from, that we don't know. But we are taking a sample, right? Now, my mean value says, the mean value from this sample says 3.5 metric ton per hectare. Metric ton per hectare. Now tell me, most likely, these farmers are from which district? Most likely, these farmers are from which district? In Tamil, இந்த டேட்டா பார்க்குற போது இந்த 20 ஃபார்மர்ஸ் இந்த அவரேஜிங் அநேகமாக எந்த டிஸ்ட்ரிக்ட்லேருந்து வந்திருக்கலாம். Similarly, in Sinhala, මේ sample mean බලනකොට 3.5 metric ton per hectare බලනකොට බොහොම දුරට මේ farmers group එක ඇවිල්ලා තියෙන්නේ කොයි district? Huh?
No.
Yeah?
Jaffna.
Jaffna. Why you gave that answer?
Somewhat near to that yield from Jaffna district.
Right, someone near to the average yield of Jaffna. Right, so that is your answer. So maybe that answer could be correct. We will see some of other examples. So again, I am taking, so we say this is from Jaffna. I'll put it as J. Right? Again, this sample from another set of sample, 20, I get a mean value, right? I get a mean value of, let's say, 6.8 metric ton per hectare. So what can I say now? Most likely, this group of farmers would have come from
Kurunagala district.
Kurunagala district, yes. Why? Because this value is much above, the mean value of Kurunagala district. So this is somewhere here. So we could say this is coming from Kurunagala district. Clear? Right, now I am going to give a tough question. I have a mean value now. 5 metric ton per hectare. 5 metric ton per hectare. Again, from the group of sample, I found out my value is 5 metric ton per hectare. So what is my decision now?
It may be from Jaffna or Kurunagala.
You can say maybe or may not, because I said you can choose only one district. You can't ask maybe, yeah. Maybe raining today, may not be raining today. That no to answer. Today it will rain. Or today no rain. Similar to that. Because null and the alternative. So So you can't accept both. Now, anybody?
Kurunagala district.
Kurunagala. Why? Why it is Kurunagala? Why not from Jaffna?
In Jaffna district, average yield is 4.
Yeah.
That is the average one also. They cannot reach more than 4. But for some reason, the average yield of Kurunagala district can be reduced.
No. When you say average, what does it mean? Because both average yield are normally distributed. So their distribution is same. Same distribution. That is what I said. They are normally distributed. So the distribution is same. Right? The area under the curve is same. So that is what distribution says. Normal distribution. So we cannot say the average yield is, since the average yield is 4, Jaffna district people cannot, this sample cannot come from Jaffna district. That is a wrong argument for the value of 5. Any other argument? Think about it. We will meet again in 5 minutes time. Have a break. 5 minutes time we will meet again, right? Okay, are you all around? Right. Any suggestions? Where could be coming from this? Where could be this particular group is coming from? Yeah. So up to now, what we have then said is that rejection rule. What you all have said is, if any value more than, let's say, 5 metric ton per hectare, then it would have come in from Kurunagala. Right? So that is the rule that we have followed. So any value that is coming from Kurunagala, any value more than 5 metric ton per hectare would have come from Kurunagala. So similarly, any value less than 5 metric ton per hectare would have come from Jaffna. Right? So this is the rule that we have applied to all these values. Now suddenly we have a value 5. So what we want to 5 metric ton per hectare. Now what is my decision? Whether it is coming from Jaffna or whether it is coming from Kurunagala. Somebody said most likely it is coming from Kurunagala. Kawuda kiwwe most likely coming from Kurunagala?
Both farmers are there.
Most farmers are there. What is the argument? Most farmers are there. No, that is not a question here.
Both Kurunagala and Jaffna, both farmers are there in that sample.
Nah, how can you say like that? Because you have to tell whether it is, this is coming from only one group, one district. This sample is coming from only one district. We don't know which district is. Maybe from Kurunagala or maybe from Jaffna. Only from either of these two districts. Randila is district in the sample one. Not from other districts. May sample aave, may district deking, ekeking indala thamai aave. We don't know which districts that sample has come. From which district that sample has come. So what is our decision? So we can't say it is coming from both districts, wrong. We will have to take one decision, right? What is the decision? Right. So here the statistician is important. So earlier we didn't talk about statistics. Why? In decision-making process. Why? Because we said this is much closer to this value is much closer to here. So that that would have come from Jaffna. So no statistics needed in that sense, common sense. So here this value is much higher than this mean value, 6.8. So most likely 99% sure that it would have come from here. Right? Now we have a junction to take a decision where this 5 metric ton, where does it come from? So it should have come from either of the district, maybe Kurunagala or maybe Jaffna. Now let's say if it is actually coming from Jaffna, and based on the decision, we come to a conclusion that is coming from Kurunagala, or we took a wrong decision. Actually, without knowing to us, it is coming from Jaffna sample. But we come to a conclusion saying that it come from Kurunagala. So, did our decision is a wrong decision, or is it a correct decision? Karosha Monakian.
Wrong.
Huh?
I couldn't get the question.
Yeah. So actually, without knowing to our sense, actually it is coming from Jaffna. But based on the data, we come to a conclusion this group of farmers are coming from Kurunagala.
Wrong.
Wrong decision, right? So that is a wrong, because I am bringing a principle here. Wrong decision. Similarly, actually, this group of farmers are coming from Kurunagala, actually, which is not known for us, statistician, right? But based on the data, we come to a conclusion, these farmers are coming from Jaffna. Again, is it a wrong decision or correct decision? Actually, these people are coming from Kurunagala, but we take a decision based on the data that these people are coming from Jaffna. Again, is it a wrong decision or correct decision?
Wrong decision.
Wrong decision. Right. Keep that in mind. I'm going to talk about some principles here. Wrong decision. Because all of us are human beings. We may take some wrong decisions as well. So how that wrong decision can be implemented here, right? So now we want to see whether this 5 metric ton, right? This group, we want to see or test. We want to see or test this group is right. So this is my objective. We want to see whether this group is coming from Jaffna. That is my objective. I will take that as an objective. Now, can you tell me what is my null hypothesis and alternative hypothesis? So, what is null and the alternative hypothesis? I want to test whether this group is coming from Jaffna district. Right. So I want to test whether this particular group, whether this particular group of farmers are coming from Jaffna district. That is my objective. Now formulate your null and the alternative hypothesis. What is your null hypothesis?
Null is mu equal to 4.
Mu equal 4. Good. What is the alternative? What is the alternative?
Not equal to 4.
Not equal 4. Good. That is also correct because mu is equal to 4. That is my null hypothesis. Mu not equal to 4. That is also good. Excellent. In this situation, in this example, if I accept that mu is not equal to 4, what does it mean? In this example, if I accept this statement, alternative, that is mu not equal to 4, what does it mean?
The group is coming from Krunagal.
Exactly. So we say that group is not coming from Jaffna. In other words, that group is coming from Pune. Right? That group is coming from Pune. Okay? Right. Keep that aside. Now we will come to some other critical point because we said this 5 is in between these two districts. The value of 5. We don't know where does it come from as an example. Right? So we may have chance to do some mistakes. Let's look at what type of mistakes that possible in statistics. Right. Now, this is my concern. I'm going to test whether these people or this group of farmers are coming from Jaffna. For that, I have formulated my null and the alternative hypothesis. Null is mu equal 4, alternative is mu not equal 4. That is my objective. Based on the objective, I have put up that. Right. Now, if I will just draw it, I will explain that. I will use another pen. I'm not sure another color is available. Let's see. All the colors are looking same when you look at through your mobile phone. That is the problem. So I cannot do anything. Do you see the difference? Doesn't matter. This is one area, this is another area. This is in black color, this is in blue color. Just make a note of it. Doesn't matter, the color doesn't matter. You can color it in your own color. This area is, right side is a different color shaded area. This is the border, right? This is the border line. That is the border line. Black color and the blue color. Doesn't matter the color. You color it in two areas. Right? Mark this area as, this is alpha. Mark this area as alpha. Mark this area as beta. I will explain what it is. Right? Still we are talking about this mean value of 5. Still we are talking about this mean value of 5 metric ton per hectare. Right? Right. Now, can you recall? We said we may do a mistake. We may do a mistake. Can you recall? Right. Look at this is what we are going to test it. Suppose, let's say, by looking at the data, by looking at the data, we reject our null hypothesis. That means we say it is not coming from Jaffna. Reject null hypothesis means that farmer group is not coming from Jaffna, isn't it? From the data, we reject our null hypothesis and accept the alternative hypothesis. But actually, these farmers are coming from Jaffna. Actually, these farmers are coming from Jaffna. But based on the data, we say farmers are not coming from Jaffna, they are coming from Kurnagal. Is it a mistake or not mistake? Actually, these farmers are coming from Jaffna. But based on the data, we say they are not coming from Jaffna, they are coming from Kurnagal. So is it a mistake or not?
Mistake.
Mistake. In statistics, we don't call it as mistake, it is an error, right? So it is an error, right? So we can write this error rejecting, I will use a better space, rejecting, I'll write that here, rejecting H0, we call it as probability of rejecting H0, or the chance of rejecting H0 when H0 is true. So this is what I have written here, right? Rejecting H0 when H0 is true. So we simply say, based on the data, we say it is not coming from Jaffna, but it is actually coming from Jaffna, right? We say it is not coming from Jaffna, it is coming from Kurnagal, but actually it is coming from Jaffna. So it is a mistake or error. So this error is called as type 1 error. It is called as type 1 error, or it is also called as alpha error. It is also called as alpha error. So this is the alpha error that I have marked in the graph, in the distribution. So in the distribution, this is the alpha error. Similarly, based on the data, we may not reject H0. We may not reject H0. That means we accept that it is coming from Jaffna. However, originally, truly, actually, it would have come from Kurnagal. So actually, it is coming from Kurnagal. Actually, it is coming from Kurnagal. So in other terms, we are not rejecting our null hypothesis, but actually it is coming from Kurnagal. So that means it is another mistake. It is another kind of mistake that is called as type 2 error. So we can write it as probability of not rejecting H0 when H0 is false. When H0 is false. Probability of not rejecting H0 when H0 is false. This is called as type 2 error, or we can call it as beta error. Type 2 error or beta error. So both are error. right? Look back again. Based on the data, we reject our null hypothesis. So this is the rejecting region. We reject our null hypothesis, but actually it is coming from this population or this distribution or this district. But we are rejecting because it is based on the data, it says that it is much closer to this value. So we reject our null hypothesis, even though our null hypothesis is a true statement. Then it is called as type 1 error. Similarly, there is a chance here not rejecting H0 because it is much closer to here. We are not rejecting H0. Somebody already said, all right, because it is closer to that, closer to that. So we are not rejecting H0, but H0 is a false statement. Not rejecting H0 means we accept that it is coming from Jaffna. However, originally, it is not really coming from Jaffna. It is coming from actually Kurnagal. Right? So this is called as type 1 error, type 2 error. So this area, if this is alpha, what is this area? 1 minus alpha. This area is 1 minus alpha. Similarly, this area is 1 minus beta. This area is 1 minus beta. This area is 1 minus alpha. Right? This area is 1 minus beta. This area is 1 minus alpha. Okay? I will talk about 1 minus beta in a few seconds. So, any questions? Alpha and beta errors. We can put up this chart. H0 is true and H0 is false, right? Reject H0, not reject H0. Reject H0, not reject H0. Can you fill this table? Where do you get alpha and beta? Can you put the alpha and beta? Can you put alpha and beta? What is alpha? Reject H0 when H0 is true. So this is alpha. Not reject H0 when H0 is false. This is beta. Not reject H0 when H0 is true. It is 1 minus alpha. Reject H0 when H0 is false. This is 1 minus beta. So you see, I have given all these 1 minus alpha, 1 minus beta, alpha, and because we talk about all probability. Probability in a continuous distribution comes as the area under the curve, right?
Sir,
Yeah.
sir, because of that, we took 5 for.
I didn't get to your point.
Why we took in 5?
No, as an example, 5 is a critical point, isn't it? As an example, we can say 5.2, 5.5 or 4.8, doesn't matter. So if it is 5 only, you will understand, isn't it? So that is why I took 5. Now we can test for 4.4, sorry, 4.8. If I take 4.8 metric ton per hectare from that average, from that group, can you say this is, since it is closer to 4, Can we say like that? No. We'll have to do a statistical analysis and see whether we accept whether it is coming from Jaffna or whether it is coming from Kurnagar. If we accept that it is coming from Jaffna, but actually if it is coming from Kurnagar, what is type of error there? We accept that it is coming from Jaffna, but actually it is coming from Kurnagar. What error is that?
Type 2 error.
Yeah, type 2 error. Good. Type 2 error.
So
Right?
then, okay.
Yeah? Oh, you can put it other way. If we reject that it is coming from Jaffna, but actually it is coming from Jaffna, what type of error is that?
Type
You
1.
reject- Yeah, because our null and the alternative hypothesis, I have erased it. We are testing our null and the alternative hypothesis, right? So based on that, we say we are rejecting this, but actually it is coming from Jaffna. So it is type 1 error. So there are two types of errors are there. Okay, type 1 error, type 2 error. We will go deeper into the error. I just introduced those two errors. So type 1 error is called as alpha error. Type 2 error is beta error. Right? Right. So if in a chart we can put like this: type 1 error and type 2 error, as well as 1 minus alpha and 1 minus beta. Among this 1 minus, because we already said alpha and beta are errors, so we keep that apart. Among this 1 minus beta, 1 minus alpha, is that the correct decision? 1 minus alpha, is that correct decision? Look at the 1 minus alpha. Not reject H0 when H0 is true. So actually it is coming from Jaffna, therefore we are not rejecting H0. Is that correct? Or is it an error? It's correct. It is coming from Jaffna, so we are not rejecting, saying that it is coming from Jaffna. Actually, it is coming from Jaffna. So no problem. We are taking a correct decision. Similarly, we are rejecting H0 when H0 is false. We say that it is coming from Kurnagar, but actually it has come from Kurnagar, where it is not coming from Jaffna. So again, it is the same decision as here. Correct decision. This is a correct decision. This is a correct decision. This is a wrong decision. Wrong decision. Now we will talk about wrong decision in few minutes. But correct decision, among these two correct decision, right? This is much more important than this. So 1 minus beta, which is a correct decision, right? This is more important than 1 minus alpha, because 1 minus beta is defined as power of the test. 1 minus beta is defined as the power of the test. So that means whenever you reduce the beta, the power of the test is increasing. Look at here. Look at this. This is the area of beta, this is the area of alpha. Can we reduce the beta by shifting this borderline to the left? If I reduce the beta by shifting this borderline to the left, what will happen to the alpha?
Increasing.
Alpha increased. So by reducing one error, we try to increase the other type of error. So that shouldn't be the case, right? If you want to reduce the beta, right? Because we want to increase the power of the test. In any test, we want to increase the power so that we want to reduce the beta. If you want to reduce the beta without compromising the alpha, we can reduce the beta. First thing, if you want to reduce the beta If you want to reduce the beta so that we can increase the power of the test, to increase the power of the test, we need to reduce the beta. One way to reduce the beta is increase the sample size. When you increase the sample size, what is happening? This distribution become more and more cube, right? So the area wise it will decrease. Can you remember we said about the distributions? So if you increase the sample size, what will happen? This is becoming as this distribution. So this area, earlier this area was, the total area was like that, right? Then now the area will be decreased as such. The area will be reduced. So that one way to reduce the beta. The second one you will learn in your final year. Applying good experimental design. You will learn this experimental design in your final year. So the other way to reduce the beta is talking about good experimental design when you apply. Right? I need 5 more minutes or 10 minutes more. Right. Now we have talked about the correct decision 1 minus alpha and 1 minus beta. So 1 minus beta is more serious than 1 minus alpha because it is giving the power of the test. Now we said two errors. Let's compare the two errors. One is alpha, the other one is beta. We cannot consider two errors always when you do the analysis. So we'll have to give a priority to one of them. So what do you say? Which error is more serious? Alpha error or beta error? Can somebody argue on alpha error or beta error?
Beta.
Beta error. Anyone else? Now, okay. Now I will. Maybe you can choose whether which error is more important. Now I'm giving a example in the judicial system, right? In the courts, when a person is guilty or not. So let's say there's one person who has brought down to the court. I want to take a decision. We want to take a decision. So what is my null hypothesis? What is my null hypothesis? Look at the reference population. What is the reference population? What is my null hypothesis? Victim, a culprit has been brought down in front of the justice. Now, based on the argument, he can be released or he can be put into the jail. Right? Based on the argument, he can put into the jail or he can be released. So what is my null hypothesis? My null hypothesis is the person is not guilty. The person is not guilty. What is the alternative hypothesis? What is the alternative? Yeah, person is guilty. Alternative is person is guilty. Now tell me, which is more serious, alpha or beta? Looking at the definition of alpha and beta. Looking at the alpha and beta, tell me which is more serious. Can you explain what is alpha in simple form? Guilty form. Can you explain what is alpha? Alpha mean, Can you tell in terms of jail, guilty, culprit, judgment and so on? What is alpha? Alpha කොහොමද කියන්න පුළුවන්? Alpha එපடி சொல்லலாம்?
The person put in the jail as he true person, not guilty person.
Right. So alpha mean we are putting the person into the jail who is not guilty. So that is alpha. We are putting a person into the jail who is not guilty. Do you understand? Who is not guilty. We are putting that person based on the evidence. Based on the evidence, we are putting him into the jail, whereas he is not guilty. So that is a mistake. That is alpha. What about the second one? Beta?
Not put into the jail, but
Is?
Releasing the guilty person.
So we can say, though the person is guilty, he is not put into the jail. Though the person is guilty, we are not putting him into the jail. So, which is more serious? Which?
second one, H1.
Huh?
Beta.
Beta is serious. Again, මොනවාද?
Releasing the guilty person.
එහෙම තියනවා නම් ලංකාව මේ වෙලාවට හැදිලා. නේ?
Alpha, sir.
Yeah, more serious is I'm talking about more serious is
Alpha.
alpha, because if you look at the low point of view, the guilty people can be released, but not a single guilty person should be punished. That is our judicial system. That is why we are in this kind of condition. So basically, alpha is more serious than beta. Alpha means putting a non-guilty person into the jail is more serious than releasing a guilty person. Go and talk to some of the lawyers, they will say, they will tell you. So alpha is more serious. Therefore, in our experiments, we consider alpha error as the most important error compared to beta error. We cannot compensate both error together, so we'll have to consider only one error. So the error that we consider always is alpha. So in the experiment, alpha is more serious, so we consider in experiments alpha error, which we call as type 1 error. Right. Okay. So hereafter, we will use the alpha error for any kind of experiment compared to beta error, because beta error is very softer compared to the alpha error. That is one thing. The second thing, how to decide this alpha error, how much error probability in terms of probability, right? How much probability alpha I can decide? 0.01, for example. This is in terms of probability. Look at these values, 0.05. Alpha is 0.1. I will give a simple explanation. This is the total area probability. So this probability is 0.01. So what is this area?
1 minus 0.0.
What is the value?
0.99.
Right? So this is the explanation for that. So here, this is called as rejecting region. Rejecting region. Okay? Now you see, alpha is a mistake. error. Now you see here this is 0.99, this is 0.01. If I draw it for the second one, all right, so this is 0.05. So what is this area?
0.95.
So likewise, you can write it to any the third one also. What do you mean by this alpha? If somebody asks what is this alpha, you should be able to explain this. So alpha is an error. So we allow the error to happen maximum of, if it is in percentage, what is this percentage? 1%. So we allow maximum 1% error. In this case, we allow, what is the percentage of error? 5% error. So here we allow maximum 1% error. Here we allow maximum 5% error. Here we allow 10% error maximum. Now you see the different research or researchers are using different alphas. For example, agriculture, basic science researchers are using alpha 0.05. Social science people are using alpha 0.1, whereas the medical people, clinical trials are much more related with alpha 0.01. Can you tell me why? Can you tell me why? Compare these two alpha, because the medical researchers, clinical trial researchers are doing with this. Agriculture, science group are doing alpha or taking the alpha as 0.05, and social science people are using the alpha 0.1. What is the reason? In medical, we allow maximum only 1% error. Why? If you allow more percentage of error, more people will die, isn't it? Mistake. It's a mistake. Error. More people will die in an experiment. So will you allow that? No. But here, agriculture, science, maybe 5% of the error. 5 plants die. Doesn't matter. If 5 plants dying compared to 5 people dying in a research, which is more serious? 5 people dying in a research is more serious, isn't it? So that is why in medical research, the alpha is very low, because it is the allowable error. It is the error that can be occur compared to the agriculture, compared to the social science. So the error value varies, or the alpha type 1 error value varies with different studies, right? Okay, right. We have some more to discuss, but we will see that next week. Any questions? Any questions? Right. One more thing I would like to show. What is Jeffrey is around? Is Jeffrey is around? Jeffrey or Kamsatvani? Kamsatvani or Jeffrey, the batch reps?